The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone. Thank you for attending today's webcast titled Autodesk CAM Overview. Today's presentation is being presented by Tad Whitchurch, Director of CAD CAM Training and Support. We also have Mark Lautenbach, Solutions Engineer with Hagerman, on the line to assist with questions. This presentation is being broadcasted in a listen-only mode. You can ask questions by typing them into the GoToWebinar control panel on the side of your screen, and Mark will address your questions throughout Tad's presentation. At the end of the broadcast, when you exit GoToWebinar, you'll be prompted to fill out a short 3-question survey. We ask that you take a few moments to provide us with your feedback. Lastly, all attendees will receive a certificate of attendance and a link to the recording of this presentation. Tad, whenever you're ready, you may begin.
Okay, thank you, Berdina, and welcome everyone. Good day. This will be a a presentation on the Autodesk CAM solutions. It's an overview of those solutions. Not really a training session, although we do training. Happy to do Inventor HSM training for you if needed. The presentation will really consist of a handful of PowerPoint slides. We'll follow that up. I'll have the software up and running, and I'll show you the ins and outs of the software, and we'll take a part. We'll program a basic simple part and post-process it and look at the setup sheet. Then we'll get into another part that has some of the advanced 2-axis, 3-axis machining on it, such as open pocket and so forth. And then we'll finish that up with some 3D machining. Show you a little bit of that also. So to start with the PowerPoints, as you know, Autodesk is now in the CAM business, and a little bit of a snapshot of them. We're really excited about this here at Hagerman and Company to have the Autodesk technicians and resources available to us to work in the CAM environment. We're already seeing, since its release, some fantastic new features added constantly. So we're really excited about that. Another thing is that Autodesk does have assigned to HSM a post-processor group. We know that GCode is the bottom line, right? So they have a group dedicated to helping resellers and customers directly with their post-processor creation or tweaks. And it's a wonderful solution for the digital prototyping statement that they have because HSM does run inside the Inventor software. Just a few slides here in case we have people in attendance that are more Inventor users and not really yet involved in the machining or the manufacturing side of it. And also to help a little bit with terminology, we have computer numerical control. Basically, CNC is the term that's used there. Many times the machine manufacturer is different than the control manufacturer, so that might be why on occasion we will ask for the control manufacturer, because that's the device that takes the G-code that we produce and makes the machine move. The G-code is a bit of a slang. It's been around forever, but it's actually using the machine in somewhat of a robotic form, if you can think of it that way. The machine reacts to the G-code that's running it. It's a language that's been around forever. You'll hear EIA standard perhaps in discussions. You can see here basically since the 60s it's been around. And the slang really comes, and you'll see in the blue picture on the right that many of the codes are G-codes. Many of the codes are also M-codes. So that's really where that comes from. Some other terminologies, we have speeds and feeds and step over. The speed is the rotation of the tool. The feed is how fast that tool moves through the material, whether it be aluminum, high-speed steel, cast iron. Feed rates adjust based on the material type, or the programmer would adjust the feed rates based on the material type and also the speed. And then we have the step over, which is how much of the tool is actually engaged with the material. Some machining center examples, because when we talk about HSM, you're going to hear things of 2.5 axis is actually a free piece of software, HSM Express. You can use that now. Download it. It doesn't include Inventor. You'll need Inventor to run it. But that's a free package that you can download now and start producing G-code and manufacturing parts. Then we get into the 3-axis, which basically the machine looks like a 2.5-axis machine, although we can use that 3rd axis, in many cases the Z-axis, in a feed environment. In 2.5-axis, Z is generally positioned while X and Y feed. In a 3-axis, X, Y, and Z can feed at the same time. Then we have 5-axis machines, basically adding a rotational or index to the picture. Indexing can be done in 90-degree, 45-degree increments, but on the rotational side of it, sometimes we run into machines where the rotational axis doesn't just index to a specific position, it can actually feed as it's indexing. And that gets us into 4th and 5th axis simultaneous, or perhaps X, Y, Z and A and B are moving at the same time in a feed environment. So just a snapshot of that. And again, some of the questions come up. This is being recorded, so you'll be able to see these images through a recording also. We get into fixture offsets. When we program parts, we use basically standard or nominal size tools, a 1-inch end mill, 3/4-inch end mill. But when you're out in the machine and you're putting a micrometer on these things, it might be 990 instead of 1 inch, or it could be 0.365 instead of 0.375. That would be where the tool offset is used, and that's done at the machine control. The G-code simply throws a T switch or a D switch or an A switch to activate the right column from within the control offsets. And then we have fixture offsets too, where you set up a part, you dial in 00, but out of the machine, well, perhaps it's not exactly 00. Maybe it's off by a little bit. They can put in fixture offsets there. So basically, from a CAM perspective, or I'm sorry, from an NC programming perspective, we program in many cases nominal sizes and around some 00 coordinate. As far as the Autodesk CAM solution, they, as you may know, they purchased this product, as they do many. Rather than reinventing the wheel, they purchase the product and bring the people with them. And so now we have an HSM kernel, and here we'll be talking about the Inventor HSM product. There's also an HSM Works that does work within the SolidWorks environment. If you have SolidWorks, you can still deal with Hagerman and Company, and we can help you with your CAM solution. And we're all here in the cloud talk, right? The 360 and the 365. HSM also has a cloud-based solution. It's called CAM 360, where you can, through your web browser, attach tools and machine parts right through the cloud. So why integrated CAM? That is what we're talking about here. It's a CAM solution that sits inside Inventor, right where the designers work. So you really have a simplified data structure here on a standalone CAM system, and Hagerman is very familiar with those, as we used to be a Smart CAM reseller and an Edge CAM reseller. Basically create your CAD data, you would export that out of Inventor or SolidWorks and import it into your standalone CAM system and then go to work. If there was a change, to the design. You would have to re-export out that CAD data, re-import that CAD data, verify your toolpath, perhaps redefine operations, redefine a setup, and re-verify. With the integrated CAM, we can eliminate many of these steps and actually streamline the workflow so that as the CAD data is created, we define the setup, and I'll get into a lot of this, the operation, verify the toolpath, and if there's a change, it's really kind of a no harm, no foul, because we just simply open up the IPT or the IAM file or the SolidWorks part or the SolidWorks Inventor, and we generate the toolpath. So there's the elimination of import and export and data translations and so forth with an integrated CAM solution like the Autodesk HSM product. A little history here, just really kind of punching a hole in what we hear sometimes out there about it being new. HSM is not new. It was developed in the early 90s by a Simco, which was a master CAM reseller at that time. They started developing the product and working on the kernel, began dealing with adaptivity, which we'll see in the demonstration, moved to a 64-bit multi-thread kernel in the HSM Works product. And look at that date, 2007. That's pretty quick. Then the distributed CAM is released. The HSM Express, again, just another bullet on that. That is a free 2.5-axis CAM solution that you're welcome to download and use right now. Then Autodesk purchased them, and just late last year we have our first cloud-based CAD CAM solution. So with the Autodesk workhorse behind it, we can expect really good things out of this HSM solution. Some of the packaging for terminology issues, the Express, as I've mentioned a couple times now, is the 2.5-axis solution. That is free. The standard product and the professional product are products that you have to pay for. Those paid products do include Inventor, and on the cloud side do include Fusion 360. So if you have a need for 3-axis machining or 4-axis, turning is coming in the future, near future, I believe late this year. And you get the standard package, you pay the money for the standard package, and then you also get a seat of Inventor. If you work with SolidWorks, you would get a seat with HSM Works, a seat of SolidWorks. Here's a snapshot that you might want to look at a little closer when you get the video recording of this. I won't spend too much time here, but it gives you an idea of the features that are a part of both the Express, the standard, and the professional. I don't know, I don't want you to hold me to those price lists up there. I'm more on the technical side. Prices change so fast, it's unbelievable. So make sure that you get a good quote on that. But you'll see down towards the bottom, if I may, the 4-axis wrap tool path, the mill turn, and the 5-axis and so forth. Those are in the purchased product. So the free product is just 2.5-axis. And just a snapshot of what people are saying. Leave that up for a second for the video recording, but you'll see that a lot of companies are very happy with what we have, and we're here at Hagerman. We've installed it and sold quite a few seats, and we're getting very positive feedback. Just a quick workflow, then I'll jump into the product. Basically, you open up the CAD data file, whether you're an Inventor or SolidWorks, it's just the IPT or the IAM. Sitting on your screen, you define a setup, or where is 00 out on the shop floor at the machine. You define the operations, and the operations in a quick snapshot would be face mill, ruffle pocket, contour around the outside or the inside of a pocket, chamfer, and then they have drilling, and that's where we'll find all of our hole making solutions under the drilling area. That's for spot drill, ream, counterbores, taps, and so forth are found there. We can simulate the tool path. Another term I've used is pixel eater, where it actually simulates the removal of material on the Inventor or SolidWorks part, and then to help you visually verify, and then you can post-process the output and send it to the machine control. So with that, I'll hit escape and we'll get out of the PowerPoint. Let me pull up a window here to make sure I'm not getting ahead of everybody. And where we are right now is we're in the Inventor product. We're in Inventor 2015, and I've opened up an Inventor part. And you'll notice the orientation is typically the first thing we run into, because designers are not really too concerned about how a part sits on a machine. So from an HSM or NC programming perspective, we have to orient the part to the machine. And we do that via the setup, and then also through the tool panel here, they have an orientation that's specific to the machine where I can orient differently from the designer. And the CAM orientation is based on the XY of the machine tool. You'll also notice in the interface that we still have all of the Inventor tools for 3D modeling, sketching, inspecting, measuring things is something that's common when NC programmers get parts. We may not know the size of that slot or the size of those holes at first look. So you have all of the Inventor tools at your disposal. The HSM product adds one ribbon to the picture, and this is the CAM ribbon. Also in the browser, you have your model browser or your assembly browser if you're an assembly file. So that look and feel is still the same, but HSM, in addition to adding the ribbon, has added a new browser for the CAM part of the product. Just to go through the workflow here, the setup area, usually we work from left to right. The setup area is where we go and we can define the work coordinate system. How is the model oriented? How is the X, or which way is the X-axis pointing? Which way is the Y-axis pointing, etc. You can also define here the stock. Right now we're dealing with the rectangular-based stock. Casting-based stock is coming shortly, where you can define the stock and you can control the side offset, the top offset, the bottom offset, and so forth. You can also just key in an XYZ for the rectangular shaped stock. And then there's the post-processor tab on the program number, name and number that you want to use. Any program comment at the beginning. And if you use a WCS, these offsets are for multiple WCSs where you may have multiple parts on a vise or multiple parts on a tombstone. We can have multiple work coordinate systems and use the H codes, I believe it is, or the M54, 53, 54, 55 to orient the work coordinate system. Once you define the stock, you begin machining. The first thing here that we'll do is I'm just going to face mill the top of the part. It brings up a new panel in the browser area, and we work here from left to right also. The first thing that we'll define is the tool, and when you pick on tool, it pulls up a library that actually comes and ships with the product. And there's probably hundreds of tools that ship with the product if I go down to the sample libraries. and give you a look at that. We can click on the sample tools, click on the mill tools, and I can scroll and you can see all of the different ball nose end mills, flat end mills. It might be a little hard to see on the screen there, but the type is listed here. It also includes holders. And you can see pictures of the holders as you select different items. Same thing with the tools. And you can also create your own new library. Although a library is automatically created for the open documents, not a library, but a tool list for the open documents. You can also create new turning tools, which will be shortly, and new milling tools also from within the product. So if you don't find what you want, you can always create it also. Each part then that might be open will have its own list of tools. From the tool library, we could go to a different library area, and just like typical Windows, I can right-click and do a copy, and then go to the part that I have open, and in here we could right-click and paste. So it's very easy to move a tool from a library to the active part. The software will do it for you automatically. If you pick the tool out of the library, it will put it in the active part. But it is a nice way from an instructional standpoint or a learning curve, or even just how you work, where maybe the first thing you do is to pick the tools that you're going to use for this part, and then you go and start programming the part. I'll pick a 2-inch face mill in this case. I'll run over to the Edit button down here just to take you through that. The Edits dialog box that comes up allows you to define the general information about the tool, for example, the tool number, any offset codes for the D word or the T word, what type of coolant do you want to use on it. Then there's the cutter definition, and you can see the flute length and the shoulder length, and everything updates on the fly as you go. As you put in these numbers, they will update dynamically. The shaft definition, in this case we don't have one, but we also have the holder definition, and you'll notice the button here with 3 dots, and we all know with 3 dots that takes us to another dialog box. Back to the tool library where I could go and pick on a different holder. The holder geometry is defined here, and as I highlight these, there's a little yellow display to show you the area that you're working with. I hope it shows up okay on this presentation. It's a little faint, kind of hard to see, but it helps you define perhaps a custom holder. And then finally the feeds and speeds tab. This is for this particular part. The programmer is still responsible for supplying the correct speeds and feeds. There's no magic button on what type of material you're working with, although you can have tool libraries based on material if you'd like. You could have, if you have a couple dozen tools that you use 90% of the time, you could build a library of those and then have all those tools be in a library called aluminum, and then perhaps have another library with duplicate tools called steel, and then define speeds and feeds differently within the 2 different libraries. So we'll select the face mill, and then as we work through the tabs, you'll see here's the stock selection, and you'll see a little checkbox that you turn on and off as we go through. Here's the depth, and this is very nice dynamically. Autodesk has done an exceptional job in giving you wonderful feedback on what the levels are and the selection process that you go through. You can define clearance height. You can define a retract height, a feed height, the top of the part, or the top of the stock in this case, and then the bottom height of your cut. Another thing that you'll find through the software is if you rest your mouse on an area, you get help, and pictures, which are very helpful in learning how to use the software. There's also a very good help system up at the top that includes a manual that you can search for or search through. You can then go to the next tab, which defines your passes. You can turn on the multiple depth switch and do different step downs. You can also define how much stock that you want to leave. And then finally, the last tab is the linking tab on how to move from one machining process, rapiding, to the next machining process. How do you want that to be handled? Do you want the tool to retract up, get out of the way, stay down? How do you want to handle the lead in and lead outs? Probably a little more important in pocket machining or contouring than face milling. But this gives you a little bit of an overview of how the software is laid out for the user. When you fill in these blanks, you hit the OK button, pull the trigger, and it will give you your toolpath on the screen. At any time, you can simulate the toolpath, and when you're in Simulate, you can define, do you want the toolpath to display on the screen or not? Do you want to see the stock? Do you want to monitor the tooling information where you can actually see the X and Y positions, any detections that are taking place? Yes, HSM does warn you about detections. Also in the simulation, if you have a collision of any sort, it will show that in red, and it will also show you those collisions here. And then more statistics of the machining time, the distance, and so forth. So also down here you have your little VCR. I guess that's probably aging me a little bit. Your DVD, your streaming tools. Hit play and it will go ahead and machine through. This particular operation and much of HSM is built around or built with high-speed machining in consideration, and we can see that with the toolpath. Where here on the green area it's actually curving to the next path. You can control the speeds and feeds through the cut, linking or transitioning to the next cut. You'll also see here some contouring in from Z, a transition from Z to X, for example. This is all with high-speed machining in mind. Yes, you have the opportunity to do just straight moves, but I wanted to mention that. So now what we can do is maybe we want to remove some material from this part, and I want to remove these material where these slots are. I'm an NC programmer, I'm not a designer. I can then jump over to the Inventor tools and use those at any time. I could use the distance and measure from a point to a point. See the size of that. Then go back to the CAM area. Say I want to do a slot operation. Go grab a tool that meets the size of those slots. And then again, like we did with the face, we move from left to right. Put in your speeds and feeds. I'll go ahead and pick the pockets. Notice that I can pick through the part. And then just a real quick thing here, step through the levels as we've done before. I'm going to check and make sure that the bottom height is the selected contours that I picked. So I purposely picked the bottom of the slots, not the top, knowing ahead of time that this option would help me, where it also defines the bottom of the cut, and pull the trigger, and it will go ahead and machine out those slots. We can then move to a pocket operation. I could use the same tool, or we'll go and grab a different tool. Just picking up the pace here a little bit to show the ease of use. The pocket selection, I'll go ahead and pick that bottom face. And at this point, I can see what the software will give me by pulling the trigger and letting the toolpath be generated. You'll notice that the browser is keeping track of the history of what we're going through. As far as programming, I can double pick that and bring it right back up and make any edits, multiple depths of cuts, and so forth, and update the toolpath very quickly. So the ease of use is very impressive from what we're used to as we've all grown up with CAM. And I think you'll find it very, very simple to use and robust. Finally, just a quick look at the hole making area here. The drill, a lot of people start, well, where's the tap? Everything is found underneath this drill icon. And another nice tool that's available to you is the ability to create folders. Because typically when we do hole making, it's a spot drill perhaps, a drill followed by a tap. And then you can reorder things with HSM to have that entire machining sequence of the hole, the spot, the drill, and the tap, all in one folder. It makes it so that we can manipulate the hole making with a much easier selection. I don't have to pick the drill, pick the spot, pick the tap to edit things or move things around. So I can create a folder. It adds that folder in the browser. I can rename it to holes. I can spell it right. Open that up, and then we can go into the drilling. And maybe the first thing we'll do here is we'll grab a spot drill, because this is really pretty neat here. Let's select that. When we move over to the Geometry tab, you'll notice that it allows us to select faces. So I could select the cylindrical face of a blind hole or a drilled hole. But for spotting in this case, I can actually select, because the designer defined the spot in the solid model, I can pick those faces. Another thing that's nice here is this button to select the same diameter. So I can turn that on and select that face, and you'll see that it quickly found the others that match. I can go with the heights. I can check the cycle and say OK, and very quickly spot drill those holes. And they're located now under the hole folder. And we can do the same thing then with the drill. And we can do the same thing with a tap. If I go to the geometry, I can pick that cylinder, make sure that checkbox is turned on, and very quickly drill those holes. Now if we simulate this, a couple things on the simulation again is you'll notice here it's just simulating the last operation that I did. So when you simulate, what is highlighted will be simulated. And this is really nice, I think, where I want to hone in on that pocket a little bit. I can select the pocket and right-click and simulate that only. And see what the toolpath will look like there. Also, of course, you can go up here to the setup and right-click on that and simulate the whole thing. Again, you can turn on the toolpath if you want to see that, the toolpath display. And then also, we have the opportunity here, this little forward button with the dot. I can just click that and go through each operation in a completed form to see more of a step-by-step as you work your way through there. One thing I might do here is maybe machine the outside contour. We'll go to the contour option, go ahead and grab another tool. Define the contour selection. Again, notice just from a learning perspective, I'm picking the bottom. I can pick the top, no big deal there, but I'm picking the bottom because when I go to the depths, the bottom height is defined by my selected contour. And we might push that down just a little bit to get the bottom of the tool below the part, and hit OK. And we can machine that contour. And I mentioned this before, don't forget you can drag and drop, just like if you're an Inventor user, how you can order things. If we simulate this, you'll notice that the simulation or the programming is how I defined them. And I'll let this run for a little bit. But you may define or decide later, you know, maybe I'd like to machine that outside profile a little bit earlier in the process. Now there I could change my heights to avoid some of that air cutting time that's going on. I could also come back and finish those. And of course this part is being held by air. But the nice thing about that, the reorder, is I can drag this up and say, you know, maybe I'll do that after I face mill. And just by simply left clicking and holding and dragging it, I've reordered the machining process of the part. To move on a bit, when you're done, it's not uncommon where you might want to generate some sort of setup sheet that might go in some routing environment that you have to communicate between the programmer and the shop floor. This is the setup sheet that was generated here from this particular tool, or I'm sorry, from this particular let's go back here. Program. So we'll take that setup sheet. Regenerate everything. If there's a change of any sort, you can right-click and regenerate the toolpath. It's nice also, it shows you percentage. So keep in mind this does do background processing, so if you do a lot of ball nose end mill for surface machining, and a lot of calculations are done, it'll process that but allow you to continue to work. Dang it, wrong button again. Okay. And there's all the tools that are listed. So a real nice formal way here. It's an HTML file. If you're using Windows Explorer, you can also right-click on that and export it to Excel. We've run into people that like their setup sheet in more of an Excel format. Another thing that you can do is under the post-process, when you generate the G-code, there is a post-processor. See if I can find it here with my glasses off. Setup sheet for an Excel format where it doesn't really produce G-code, but it does export out the setup sheet into an Excel file format. Very nice, and we're running into a lot of people that use that. But to get to the post-processor where you generate the G-code, here's a list of, I have all selected. I'll change this to milling. Turning isn't here yet. And give you, starting at the top, just a quick snapshot of some of the tools or some of the post-processors that are available out of the box. Getting very good feedback on these from our customers, and I'll scroll so that you can get that also listed when you view the video later. So a lot of machines available. I'm just going to stick with the Okuma, no particular reason, just sticking with it. and then we'll post this out, and you can create an extension on here. It could be whatever extension you need. I know sometimes the control really defines the extension that's needed, so you could do a .nc or leave it blank, or a .min, and we'll go ahead and save that. And it pulls up for us the GCode editor. This editor comes with the product. There's no charge for it. They also sell this editor, I think it's $500, through the Simco website, in case you wanted to put the editor out on the shop floor someplace. You'll notice a little color coding going on there at the top, and some posts color code a little different, where you'll get a different color around the tool change area, perhaps a different color for hole making, your G81, your G82s, or so forth. Here's the contouring. So typical G-code, nice input here on the tool setup. It does support subroutines. It does also support manual tool changes, where you maybe put out an M0 and allow the machinist to load the tools. So the editor is very good. The editor also has the ability to minimize this. Do compare, renumber, adjust the feed rate and speed. Right here it'll search for your F codes or your S codes and allow you to make quick adjustments in the editor. Obviously the goal is to not really have to edit this, and that's where the HSM post-processor team is good at, where they'll tweak. If you have a post and you have a part, you can send them or send us, whichever, we can be your go-to there. Send us the IPT file or the IAM file that contains the program. Send us the G-code output that you got using one of the generic or pre-installed post-processors, and then send us a separate file with your tweaks or changes. We can upload that to the post team, and they'll tweak that for you. There's also a backplot function here, and a lot of people like this, where you can pull up a backplot window, and it'll actually show you the movement from the G-code as you go through, and basically show you the tool path. Now the part's not here because this is strictly showing you what the G-code is producing. But very nice. You can zoom in and zoom out, rotate things around, and so forth. File compare is nice. If you have a G-code file and you perhaps the machinist did some editing out there and sends it back to you, you could open up two NC G-code files and compare those side by side, and the software will highlight the differences. The transmission tab, it's kind of like a mini DNC area where you can send a file directly to a machine tool from within Inventor HSM, or from within the editor, I probably should say. And there's a setup button here where you can go and define your machine tools, what's the protocol for that control, what type of port it needs, and then any certain ISO or post-processor tweaking there. And then when you send the file, you simply send the post file. Guess I'd have to go pick the NC file. And it would open up the port and send it. I guess I'm on a network here at the office. But I want to show you can send and receive from a machine control as long as it's set up appropriately with the right protocol. That's a very quick overview. Just to expand on this a little bit, Here's a part that's a little more aggressive in some of the machining practices, but I do want to point out that you'll notice that we can do slots, or I'm sorry, open-end pockets. Right-click. If you're looking for anything, just right-click. And then you can also simulate the whole thing here, but it gets into thread machining that you'll see primarily in the Inventor HSM product. Also, I like the slot machining for open-ended slots where it'll go in and out. The open pocket, again, that's a big deal for me. That's typically where CAM systems have a little bit of an issue. And then, so this part is a general overview, and I use this a lot in the instructional standpoint to give people some reference on more than a few different options. And we can simulate this just to give you an idea. I don't want to see the face. I can click the button, move on to the next face type. This is more of a clearance area here to machine out material. You'll notice it's moving down on the Z-axis and avoiding features of the part as it steps down. Then we can get more into the different pockets. And some cleanup. Some hole making and some thread machining. And it is a full 3-axis. The HSM, the Inventor HSM, does support full 3-axis ball nose surface machining, and it's very good at it. Here's an example of a couple different setups that we run through for different surface selection. Open up the pocket, and again you can reorder many of these processes using the browser. A couple other operations up here. We have, of course, the parallel lace, very popular with surface machining, where you can control the step over. Another term that you'll hear, cusp height. We have, excuse me, the ability to use the scallop operation. This is used a lot to finish entire parts. The pencil is used a lot where you remove most of the material with a larger tool, and then you have a real small radius. You might want to load a tiny pencil type tool, and then a pencil mill in deep crevices, deep areas that are hard to reach. Radial does spiral machining more in a radial fashion. Morph spiral, similar obviously to spiral, but it's based on a boundary. And then projection is nice too. We get a lot of questions on engraving. The projection operation can help you with that. Also, the slot operation, I've used this before, can also work well with engraving if it's not just a tip, like the tip of a center drill that you're going in there, 2 or 3 thousandths or 10 thousandths to engrave. If the engraving is a little more complicated than that, the slot tool is another nice way to use that. We can also use patterns, and patterns are a wonderful way if your shop is set up and fixtured where you can machine multiple parts within one, quote, setup, if you will. Excuse me. You can machine a part and then use the pattern tool to duplicate that machining sequence an X or a Y increment. And when using pattern, there's also checkboxes in there that allow you to control whether or not you want to machine the part complete before moving to the next part or next setup, or would you prefer to have the pattern work based on tools. So you would machine the top of one, and it would go over and start the pattern to machine the top on the others. You would then maybe contour the outside on one, and then it would move over and contour the outside on the others. So really the bottom line is, you don't, if you have multiple setups, you don't have to program multiple parts. You can just program one part and use the pattern option to help you with that. Okay, let's see here. Now the right click is where you can find many of the same operations that are up in the ribbon. Another thing that's nice here, didn't really get into this too much, but we do discuss it in training, is the template. If you have an operation that you do a lot of slot machining for keyways or something like that, you can create an operation, or take an operation, I should say, and create a template and store that as a Inventor HSM template. It actually produces it into the template folder. It's a little folder file, and then if you move to another part, or you start programming parts, you could then go and retrieve that template and it will take all of that functionality and bring it into the program that you're working on. So very nice feature there. Notice it brings in the tool. All you have to do now is go out and select the geometry. So templates are great for standardizing machining practices. And you could program a whole part just recalling a template, recalling a template, and recalling a template. That is really the overview that I have for you. Obviously, an hour is not really enough to train somebody on it, but we do run training classes. Most of them are one day, where we can go through everything in more detail here than in a one-on-one environment. I've done some training in a conference room with a bunch of NC programmers that didn't know Inventor. We've also done training with clients that do know Inventor but aren't familiar with CAM. So right now it's really company-specific training appears to be working the best, rather than a classroom environment where we're bringing in multiple companies. Different companies have different needs. So we want to work with you on that. We want to make you successful, and right now it looks about like one day of training is really all that's needed for either an Inventor user or a non-Inventor user. So don't let it intimidate you. We also have companies that download the HSM Express, stick their toe in the water, get their nails dirty a little bit, start working with it. We do also offer telephone support if you're interested in that, where we can help you either via the telephone or a GoToMeeting. So I want to thank everybody for taking time out of their busy day, and a movie, this has been recorded, so we'll send you a link to that, as Berdina mentioned. But wanted to look through the questions area here and see if there's any outstanding questions. Looks pretty clean. I don't quite understand that one. Can you trickle the program? Okay, from the editor. I used the term spoon feed, maybe. Yeah. The transition is, based on the communication between the machine, and I've seen it where the machine can only handle so much at a time. Yeah, we can do that, but obviously there'd be traffic that's going through there. Any other questions that I might be able to answer? Again, a big thank you to Mark for helping me out and hopefully answering your questions on the fly as we go. Also, after the recording is over, if you have questions that we didn't answer, internally here we'll get a sheet and we'll look over those questions, and if it wasn't answered, we'll make sure and get you an answer. That concludes really my portion of the presentation. I'll monitor the chat or questions window a little bit longer.
Thanks everyone for attending the presentation. As Ted mentioned, if you have questions, you can keep asking them. He's going to monitor the question box for a few more minutes. After we close the session, if you think of a question, you can reply to the confirmation or reminder email that you received from GoToWebinar, and we can route those to Mark or Tad to get your questions answered. Also, as a reminder, you will be receiving an email containing a link to the recording of the presentation. And when you exit your session, you'll be prompted to complete a short 3-question survey. We would greatly appreciate your feedback on that. So thanks for attending and have a great day.